Hi everyone, I am Mumali Vinci. We are going to discuss about stack concept in data structure. Data structures are generally classified into two types, primitive data structure, non-primitive data structure. But based on the arrangement and structure, it is again classified into two types, linear data structure and non-linear data structure. In linear data structure, there are three types: queues, stacks, and arrays. Now we are going to discuss about stack concept, which is one of the type of linear data structure. What do you mean by stack? Stacks are a fundamental data structure in computer science, providing a way to store and manipulate data in a lost in first out manner. They are versatile and have numerous applications, from tracking functions calls to evaluating mathematical expressions. In simple words, stack has only one end. The both insertion and deletion operations can be performed through only one end. Properties of a stack. LIFO structure. The last element added to the stack is the first one to be removed. For example, in your real lifetime, let's take an example. You have a mobile phone and you are listening to a song. Now there is an incoming call coming for you. Now you need to attend the call or decline the call to continue the song. This is the example of LIFO structure. And bounded size. Stacks have a finite capacity and limited by the available memory or storage. If I have created the stack to insert the element 5, then we can only insert only 5 elements. We can't insert an element 6. This is one of the drawback. Dynamic resizing. Stacks can grow or shrink in size as the elements are pushed or popped. Fast access. The element accessing the top element of the stack is a constant type operation. Stack operation. There are four operations: push, pop, peek is empty. Push operation adds an element to the top of the stack. Push operation is used to insert an element to the stock. If in a 5 element, first I am going to insert the element 10. I have used the push operation. Pop operation. Pop operation removes and returns the top element from the stack. In the pop operation is used only removes the top element which is on the stack. Peek retrieves the top element without removing it from the stack. By using the peek operation, we can see the top element without removing it. Isempty function. Isempty function is checks if the stack is empty or not. Again I have another function called isFull. It check if the stack is full or not. If the stack is full, then it is stack overflow. If the stack is empty, then it is stack underflow. Implementing stacks with arrays. Array based implementation. Stacks can be efficiently implemented using an array data structure where elements are added and removed from the top of the stack. Fixed vs dynamic sizing. Arrays can have a fixed capacity or be dynamically resized to accommodate growing stacks. But we always prefer dynamic sizing, because fixed sizing may cause a large memory space. So we prefer dynamic sizing. Pros and cons. Array-based stacks offer constant time access and space efficiently, but have limitations in dynamic resizing and maximum size. Then implementing stacks with linked list. Linked list structure. Stacks can also be implemented using a single linked list where the top of the stack is the head of the list. Dynamic resizing. In a linked list, there is no limited memory space. We can store the elements dynamically. It's a main advantage in the linked list. Memory overhead. Linked list based stacks have higher memory overhead due to the additional nodes required to store the element and next pointer. Now you are going to see applications. What are the applications? Major applications. Balanced parenthesis. The stack is a linear type of linear data structure, so it checks a sequentially checks. Stacks are used to verify if a sequence of parentheses is balanced. Then infix to postfix conversion. Stack is applied to convert the mathematical expressions from infix to postfix notations. Function called tracking. Stacks are used here to track the function called addresses. Backtracking algorithms. Here the stacks are employed in various backtracking algorithms such as depth first search to search the elements. Now we are going to see push operation. Push operation, first to add the element, we have to update the top so that we can add the element and increment the size of the stack. Then pop operation. To pop out the element from the stack, we have to retrieve the top and update top and decrement the size. Retrieve top. The top element of the stack is retrieved and returned. Update top. The stack's top pointer is updated to the next element in the stack. Decrement size. We have to decrement the size so that the top value will be decrement. The top value have the element inside the stack. The size of the stack is decremented to reflect the removed element. Now let's see the push and pop operation with the example model. The syntax of the push: void push int value comma int n. Int value, we are going to pass the value which we are going to insert the element in the stack. Int n, the total number of elements we can push it into the stack. If top value is equal to total value, then it is the stack is full, then we cannot insert any elements, so it is overflow. If the if condition is false, it goes to else, where the top can be incremented and store the values which we have passed. Now let's take an empty stack. Now I am going to insert a first element called white color. So here int val is going to be a violet. Int n is equal to 5 because I am going to insert an element, total number of elements 5 colors, and initially we have set top equal to -1. Now if condition checks, if top equal to -1 is equal to 5, the if condition is false, then it goes to else condition. Now the top is incremented, which the top is 0. Now the top value is 0, the top equal to 0, the violet color is stored. Next I am going to insert the color orange. Now again I am checking the if condition, it is false, then I am going for a else, and the top value is incremented. Now the top value is equal to 1. Now the orange color is stored in top value is equal to 1. Now I am going to check if top is equal to n. My top value is equal to 1, it is not equal to, so if condition is false, then I am going for else condition. Top is equal to top plus 1, then my top value is incremented to top equal to 2. Now the color Turkish blue is stored in top value 2. Next I am going to push the color black. Now again I am checking the if condition, if the top value is equal to n, but it is false, again I am going for else, top equal to +1. Now my top value is incremented to 3, so stack of top, which means that stack of 3 color is black, is stored in top value 3. Again I am checking. Next I am checking the condition, if condition, then it is false. So my else condition, I am going to increment the top value 4. Now my top value is 4. I am going to store the color blue in top value 4. If I have to increment another color yellow, now I have already implemented 5 colors. I have also created my stack as 5 elements can only be stored. If I have to insert another color yellow, I can't store, it prints overflow statement. This is how we can insert the push any elements using push operation. By using peek operation, we can see which is the top element in my stack. In my stack, my top element is blue color. By using peek function, I can see which color is top of my stack. Now we are going for a pop operation. Pop operation syntax: top if top equal to -1. Minus or top equal to -1 means it is an empty stack, which means underflow, or if it is true, then we can't pop out the element from the stack. Else condition, what will we do? It return the top decrement. We can decrement the top value so that we can pop out the element from the stack. Now I am going to empty the stack using pop operation. First I am going to pop out the blue color which is in top value is equal to 4. Now I have decrement the now I have checked the if condition. If the if condition is false, then it going to else. The else condition will decrement the top value. Now my top value is equal to 3, so I can pop out the element blue. To pop out the element black, again I am going to check my if condition. It is false, then in else condition I am going to decrement the top sides, which means my top value is equal to 2. Now I can pop out the element black color from the stack. Then I am going to pop out the element turkish blue. Now again I am going to check the condition. If condition it is false, then again I am going to else condition, which means I am going to reduce my top value, which means my top value is equal to 1. So I can pop out the element turkish blue. And to pop out the element orange, I am going to check if my if condition is true. No, it is false, then I am going to else condition, return stack of top minus minus my now my top value is equal to 0. Then I am going to pop out the orange element. Now I have only one element violet. Now again I am going to check if top equal to minus 1. No, it is because my top value is equal to 1. So I am going to else condition. So I am going to again reduce my top value, which means top equal to minus 1. So I am going to pop out the lowest element violet color. Then again I am going to check if there is an element to pop out. If top is equal to minus 1 is equal to minus 1, then it is true. So we this my stack is empty, so I can't pop out the any element from the stack. Now it going to print underflow. This is how we can pop out the element from the stack using a pop function. That's all. Thank you.